Okay, so we're quickly going to go through the Kinematics unit test, going over questions so that you know how to do all of these questions. If you still have any questions or concerns about anything on this test after this video, please let me know. Okay, now the questions on this test are all kind of in a randomized order, and so everybody had different questions and different orders with different values. And so the answers that you see might not match the answers that you actually had on your test. Okay, but the process for doing those questions is going to be the same. And so pay close attention to the process and make sure that you're showing enough work. Okay, so we're going to start with question number 1C. Okay, so question number 1C says a truck has an initial speed of 19 meters per second. Okay, so I'm going to label this as U. That is going to be my initial velocity. It slows down at 3.6 meters per second squared. Now, a lot of people had issues with labeling this as negative 3.6 meters per second squared. Now, do they tell you the negative sign? No. But look, if the 19 is the initial velocity, and that's moving in the positive direction, if the truck is slowing down, it should have a negative acceleration. Okay, so that should be negative. They're asking basically how far the truck goes before it stops. If it's stopping, that means the final velocity will be 0. And so we are asked basically for S, which is the displacement. We wanted to choose the equation that has those variables. We plug into the equation. And then we're just going to solve this for S. Okay, so 0 squared is 0. 19 squared is 361. Plus 2 times negative 3.6 is negative 7.2 S. I subtract the 361. And then I'm going to divide both sides by the negative 7.2. And that gives me my displacement in this case, which is 50.1 meters. And of course, that is not going to be the same value that you have because each test had different numbers. Okay, but that's how you would approach question 1C. Pause it there if you need to look at that. Okay, so question number 3E. Okay, Mac Brown rides Bevo 119 meters north into town. He then turns around and rides south for 101 meters. Assuming a coordinate system where north is the positive direction, calculate Mac Brown's displacement from his starting position. Okay, well, let's say his starting position, let's just call that xi equals 0 meters. So what is his final position? Well, he goes 119 meters north. Then he turns around and goes back 101 meters. Okay, so this is where he started. This is where he ended up. What is his final position? Well, that would just be 18 meters. Okay, so his final position is 18 meters. So his displacement, which is his final minus his initial position, is just 18 meters. Okay, so that's question number 3E. Okay, pause it there if you need to look at that. Question number 2A. It says an object is thrown upwards. The graph shows variation with time t of the velocity v of the object. Calculate the displacement of this object at t equals 1.5 seconds. Okay, so a couple things. Number one, you had to know that on a velocity time graph, the displacement is the area under the graph. Okay, if you didn't know that, there's no way for you to answer this question. Okay, if you at least indicated that you had an idea about that, then you got some partial credit, even if you got the wrong answer. Okay, this is why it's always important that you show your work. Because if you indicated that you at least knew this fact by showing enough work, then I gave you some points. Okay, then you actually had to calculate the area going up to 1.5 seconds. Now, first of all, the area here, or the area under a graph, is the area between the graph itself and the x-axis. Okay, so you have a triangle, you have another triangle, and then you had another triangle. So basically you have 3 triangles. And luckily for you, they're all the same size. The first one the area of a triangle is 1/2 base times height. So the first one is 1/2 times 0.5 times 5 plus the area of the second one is 1/2 times 0.5 times -5. Now, why -5? Because this area here for the middle triangle is negative because it goes below the 0 line. Okay, I spent a lot of time telling you multiple times that you can have negative area. Okay, that's -5 right there. Then you have one more triangle that's the same area as the first. That has an area of 1/2 times 0.5 times 5. These two cancel out because they're the same number, just with opposite signs. And so the answer to the question is 1/2 times 0.5 times 5, which should be positive 1.25 meters. Okay, so that is the answer for that question. Okay, pause it there if you need to look at it some more. Okay, next question. Question 5b. Ball is tossed vertically upwards with a speed of 4.1 meters per second. After how many seconds will the ball return to its initial position? Calculate your answer to 2 decimal places. I was very generous in giving partial credit for this problem because a lot of people only did half of the problem. What a lot of people did is they found the initial velocity, and they kind of had the idea that the ball goes up, and when the ball goes up at its highest point, it reaches velocity of 0 meters per second. And so what a lot of people did is they did 0 equals 4.1 plus -10 times t, and they calculate t to be 0.41 seconds. But this is only the time up. Okay, the time to go from this initial velocity to 0, that's only half of the trip. Okay, if it takes 0.41 seconds to go up, it also takes the same amount of time to go down. As long as the heights are the same, then the time up and the time down are the same. And so the answer to the question should have been double that time, which is 0.82 seconds with these values. Okay, so pause there if you need to look at question 5b some more. Okay. Question 4b. Okay, we have a velocity time graph. Calculate the acceleration of this object at t equals 4 seconds. Okay, so this is a velocity time graph. Acceleration on a velocity time graph is calculated by finding the slope. If you did not know that, then there's not a good way for you to have answered this question and gotten full credit. Okay, so you had to indicate that you knew you were supposed to be finding the slope, then you actually had to calculate the slope. Okay, so for slope is rise over run. Okay, so it starts at 0, 0. You go up 5, over 5. That's 5 seconds. That's 5 meters per second. So, change in y over change in x. That gives you 5 over 5, which is 1 meter per second squared. And you're done. Okay, now it says to find the acceleration at 4 seconds. But if you look at the graph, this graph is showing constant acceleration because it's linear and it's a velocity time graph. And so it would be 1 meter per second squared at any time. Okay, so pause there if you need to look at 4b some more. Okay, next question. Question 6d. An arrow is launched straight up into the air. Assuming the arrow leaves the bow at 12.3 meters per second, calculate the maximum height. So if we're looking for how high does the arrow go, we're trying to find displacement. That's our unknown. We have the initial velocity, u. And it's also a free fall question, so we have the acceleration due to gravity that's -10 meters per second squared. Plus, at maximum height, remember the arrow stops moving up, which means the velocity is 0 meters per second. Sorry, the final velocity is 0 meters per second. So we choose the equation that has those variables. It should be this one right here. We have 0 squared equals 12.3 squared plus 2 times -10 times s, which is our unknown. I can simplify a little bit. 12.3 squared, that's 151.29 plus -20 times s. And then I just do a little bit of algebra, and I get s equals 7.6 meters, and that is the maximum height reached by the arrow. Okay, and so that is question 6D. Okay, pause there if you need to look at that some more. Okay, next question. Okay, this one, they give us an acceleration time graph. They ask about the change in velocity. Okay, change in velocity on an acceleration time graph is the area under the graph. And if you watched the motion graph video and you took good notes, then you should know that. Okay, acceleration time graph, the area under an acceleration time graph represents the change in velocity. That was in that video. Okay, so basically from 0 seconds to 6 seconds, so from here to here, we need to find that area. Okay, so we have basically a rectangle, and then we have another rectangle, and then we have a triangle. And so that area would be equal to, okay, so the first one would be 1 times 2. Wow, miswrote that. Okay, so 1 times 2 plus the area of this second rectangle down here. It goes from 2 to 6 seconds. So the length is 4 and the height is 1. And then the area of this triangle up here, that has a base of 4, a height of 2, because it goes from 1 to 3. Okay, so a height of 2, a base of 4, so 1/2 times 2 times 4. And that gives us 2 plus 4 plus 4, which is 10 meters per second. And so there's a change in velocity of 10 meters per second. Okay, so that is question 9A. Pause it there if you need to look at that some more. Okay, question 7F. A lot of people really overthought question 7F. The magnitude of her displacement from point P to point Q. Okay, so here's point P. Here's point Q. Displacement is final position minus initial position. Nothing else in between matters. So, in other words, the semicircle doesn't really make a difference. If we had just gone straight from point P to point Q, the displacement would be the same. So we have 4 plus from here to here is 2. How do I know that? Because that's the radius of the circle. Okay, so from here to here is 2. From here to here is another 2. So in other words, if the radius is 2 meters, that means the diameter is 4 meters, and 4 plus 4 equals 8. Okay, that's it. A lot of people got obsessed by the semicircle part. They thought, circumference has something to do with it. No. Okay, way overthinking it. Okay, so that's question 7F. Okay, question 8G was actually kind of a complicated question. And so you have to, pay close attention to the graph that you're looking at and interpret everything correctly. Okay, now we're given a velocity time graph, and only one of these statements is true. Okay, so let's go one at a time and try to eliminate some of these. The truck is always accelerating. Okay, on a velocity time graph, acceleration has to do with the slope. Okay, so is the slope of this graph ever equal to 0? In other words, is the slope ever horizontal? Because that would indicate a slope of 0. And looking at the graph, I don't think so, and so this is a maybe. B says the truck is always moving. Okay, so let's think about that for a second. If the truck were to stop moving, if it were to stop, that means that the velocity would be equal to 0. Is the velocity ever equal to 0? Well, yeah, right there. There's a graph, it crosses the 0 right there, boom. So B is out, okay, because right at this time right here, it stops moving. C says the truck is always moving in one direction. Well, up here, between this point and this point, it has a positive velocity, meaning it's moving in the positive direction. And from here to here, it's moving in the negative direction. So, no, it's not always moving in one direction. C is out. And then D says the displacement of the truck after time t is 0. On a velocity time graph, displacement corresponds to area under the graph. Now, is it possible to get an area of 0? Yes, as long as the positive area and negative area cancel each other out. So you have to ask yourself, this area right here is a positive area. That's where the object had a positive velocity and was moving in the positive direction. Is that going to cancel out completely with this area of this shape down here? Now, obviously, these are weird curves, and I wouldn't expect you to be able to calculate the area, but visually speaking, you should be able to see that this is way more area than that, okay, which means they don't cancel out, which means D doesn't make any sense, which means the answer has to be A. Okay, so that is question 8G. Pause there if you need to look at that some more. Okay, now we get to the long free response questions. Some of these are very straightforward and some of them are not. I'm going to try to go quickly through these, and so please pause it and rewind if you need to look over them some more. Okay, and by the way, there are different versions of all these questions, and so some of them might look different than the one you had. That's fine because the approach to all of them was the same. So superpowered Uber van in Irving starts to move from rest, that means the initial velocity is 0, in 2 stages. During stage 1, the van accelerates at a constant rate of 4.72 meters per second squared. I know that's the acceleration because, well, the unit, meters per second squared, until it is moving at a cruising speed of 89 meters per second. So this is my final velocity, okay, for stage 1, and then during stage 2, once it reaches this cruising speed, it travels at a constant velocity until it has nearly reached its destination. Now, people did really good on 10A and 10B. Calculate the time it takes to reach this cruising velocity. So if we're trying to find time, and I have V, U, and A, I'm just using this equation right here, and I'm just going to plug in and solve for T. Okay, so T would be, in this case, 89 over 4.72. And so, of course, your answers are going to be different, but the approach is going to be the same. That should be about 18.9 seconds. Calculate how far the van travels during stage 1. It's the same question as A, except now instead of looking for time, if we want to know how far is always a question about displacement. And so you could use any number of equations. I'm going to use this one right here, that S equals ut plus 1/2 at squared. Now, because the initial velocity is 0, that makes this very easy to do. Okay, and so 18.9 squared, 18.9 squared times 4.72 times 0.5 is about 843 meters. And if it's a little off because of rounding, that's fine. So that's 10A and 10B. Okay, pause there if you need to look at that some more. When approaching Addison, which is approximately 27,945 meters from Irving, the van rolls through the city without stopping. Using your answer for part A and part B, calculate the total time during which the van is moving. Now this is a 3-point question. Here's why. Number 1, the van is now in stage 2. It still has to travel 27,945 meters minus the 843 meters that it just traveled in stage 1. Okay, so the first point for this question is for subtracting to get 27,102 meters. That's how far the van still has to travel. Okay, because it traveled a little bit while it was in stage 1, but most of the time it's in stage 2. And for some reason, most people seem to ignore the fact that stage 2 is constant velocity. Okay, stage 2 is a constant velocity problem. That means all you had to do was S equals V times T. If you did anything other than S equals V times T, if you use any constant acceleration equations, you lost a lot of points, okay? Because constant velocity, you can only use the constant velocity equation. So it should be 27,102 equals 89 times t. Okay, so you would divide to get that t, and that would be the t from stage 2. That's 304.5 seconds. And then the last step would be to add T1 plus T2, so 18.9 plus 304.5, and that is 323.4 seconds. Okay, and very few people got full points on that because most people did not realize that this stage 2 is constant velocity. Okay, so pause it there if you need to look at that question some more. Okay, I'm going to erase to clear some room. Okay, for the last question, the van begins to stop. That means the final velocity is going to be 0 meters per second over a distance of 2,000 meters. So that's how far it travels. That's the displacement as it's slowing down. The initial velocity was however fast it was moving while it was cruising, which in this case is 89 meters per second, and we're asked to find A. Okay, so once again, this is a pretty straightforward kinematics problem. You plug in your values and you solve for A. And in this case, if we do that correctly, 89 squared divided by 4,000, we should get negative 1.98 meters per second squared. Okay, so pause it there if you need to look at that some more. Okay, moving on. Question 11. I did not grade question C because on a couple of the versions, there was an issue with question C, so I only graded A and B, and a lot of people did pretty good on A and B. It's just asking you to find the acceleration for the different stages. Okay, so in both cases, you're using this equation right here. Now for stage 1, the time is 3.5 seconds. The initial velocity is 0. And then at the end of the stage, in this case, it's going 55 meters per second. So for A, it would be 55 equals 0 plus A times 3.5. And so A would just be 55 divided by 3.5. Make sure you're showing a sufficient amount of work. By the way, you should always write down the equation before you go to plug in numbers, just like I did right here. Okay, and so this is what it would be for A. Now for B, again, most people did fine on this question. Most people realize that the time for stage 2 is just the difference between these two times. So 12 minus 3.5 is the time it takes for stage 2 in this case, which is 8.5 seconds. Where some people went wrong for B though, was when you go to plug into the equation, the initial velocity is not 0. Because in stage 2 starts immediately after stage 1, and so the initial velocity is 55. The final velocity is 310. And now the time is 8.5 seconds. And so you had to subtract 310 minus 55 is 255 equals A times 8.5, and then divide to get the stage 2 acceleration. Okay, so that should be 30 meters per second squared, and that is for B. So that's question 11. That's only worth 2 points, by the way. I know it says it's a 4-point question, but because I did not grade question C for anybody, the most points you could have got for 11 was 2. Okay, so pause it there if you need to look at that some more. Okay, and finally the last question, question 12. We did a question exactly like this on a warm-up. We did questions like this in class, plus on the practice worksheet, so there is no reason to have missed this question at all. So we're basically on a cliff. Brittany's on a cliff, and she throws stone up, and then it goes down into the sea below. Okay, and we're asked to find the maximum height reached by the stone as measured from the point where it's thrown. So we know it's a free fall problem because we've seen this before. This is the initial velocity. This is not relevant to the first question, right? Because we're actually looking for displacement in part A. And we're told the magnitude of the acceleration due to gravity is 10 meters per second squared. Okay, of course the direction is down, so if you're using a normal coordinate system, then you would make the acceleration negative. So we choose the equation that has all of our variables. It should be this one right here. We go to plug in. And then we solve. So I do 11.4 squared divided by 20, and that should be 6.5 meters, and that is the answer for 12A. 12B, calculate the time for the stone to reach the surface of the sea after leaving Brittany's hands. There's two ways to do this. My preferred way would be to find the time up and the time down and add the two together. For the time up, at the highest point, the velocity is 0. And so basically, if we want the time up, we have the initial velocity, and we have the final velocity, and we have the acceleration. And so we basically have everything we had for part A, except instead of looking for displacement, we're looking for time. So I would use this equation right here, and I would plug in. And if you do that, you should get T up equals 1.14 seconds. Now, what about T down? Well, at the highest point, the object starts to fall down from rest, meaning the initial velocity is 0. The time is unknown. We have the acceleration, and the displacement is now going to be negative, and it's going to be negative 6.5 plus 113, because now we have to take into account that falls all the way down. So from beginning to end, it has a displacement of negative 6.5 plus 113 meters. And so that would be negative 119.5 meters. The negative sign is important. And so I would use this equation right here. Negative 119.5 equals, because the initial velocity is 0, this whole first term is going to be 0 because 0 times t is 0. And so all I have left is 1/2 times negative 10 times t squared. And this t that I'm solving for right now is going to be the time down. Okay, so I divide, I take the square root, yada yada, and I get 4.89 seconds, and that's going to be t down. And so my last step would just be to add t up plus t down. 1.14 plus 4.89 is 6.03 seconds. And that is a 3-point question right there. And it seems like a lot, and it is, which is why it's a 3-point question. But to be fair, we did a question just like that in class. And you had multiple questions like that on your practice worksheet. Okay, so pause there if you need to look at 12, or part B. And then the last question on the test, I'm going to erase this, so pause it here if you need to look at that some more. The last question on the test, sketch a velocity time graph, an acceleration time graph for this situation. Okay, again, we did this exact type of situation. In fact, it was a warm-up, like a day or two before the test, was basically asking you to sketch the graphs for this type of situation. The velocity time graph is going to be linear because it is constant velocity. It should have a negative slope because the slope on a velocity time graph represents the acceleration. And so it should be something like this. Here's where it reaches maximum height. And then the acceleration time graph should be constant because it's constant acceleration, because it's in free fall, with a magnitude of -10 meters per second squared. Okay, so that's it for that last question. Okay, so please let me know if you have any other questions about anything on the test. And I'll see you guys in the next video.